Hi, let's try some exercise question about the terminal velocity. So please pause the video now and finish the question on page number 9.
A few moments later.
Alright, so the first question is about skydiving, and that is something to do with terminal velocity, very likely. It asks you what happened at B and D. And so at B and D is on the graph here, on a speed time graph. So if you look at the speed before B, it is a constant, so probably it is terminal velocity. And afterwards it decreased drastically, and so very likely B is when you opened the parachute. Alright, so like what we have earlier, increasing the surface area and increasing the air resistance, and therefore you have a great deceleration. At D is when you reach the second terminal velocity and then you just decelerate to 0. So I think D is like when you land on the ground simply. And so for part 2, I ask you to draw a free body diagram at A and C. So at A and C, so let's do A first. A is you have certain acceleration still, so that is obviously in the air before you open. Well, actually it doesn't really matter, you also have air resistance, okay, but then you are increasing the speed downward, so that means the force should be greater towards the ground, so that means that would be the weight. Okay, I tend to always spell the full name instead of just put down the symbol W. So weight. The upward force will simply be air resistance. Okay, so once again to remind you, the arrow that you have for upward should be shorter than the lower one, because the lower one the force should win. Okay, so net force should point downward so that you can accelerate towards the ground. For C, then it is when you opened the parachute already, and you can see this should be a deceleration, because if you look at the slope, this is negative. And so for C, okay, label that this is A, this is C. You should still have the same weight. Okay, I will do the same length from part A, but then this time you have much greater air resistance, so the length of air resistance should be much longer than the weight itself. Okay, so this is, I think this is acceptable. Alright, going down here the two past paper question. So the first one is saying a small steel ball is dropped from a balcony, no air resistance, which one? Okay, so it will accelerate, constant acceleration. Yeah, so the answer is A. It won't be B, obviously, it will accelerate, and it won't have a increasing acceleration, because this is due to gravity, and well, we learned earlier that it is a constant rate, so no matter what ball you're dropping, is still always the same acceleration. Part B is asking you another question that is no resultant force will be needed. When a car changes direction, you need resultant force. So this is wrong, because when you change direction, think about, like say for example, the car have a velocity going in this direction, and then now you want to change its direction. So that means there must be, let's say this is V1 and V2, there must be a change of velocity, delta V. And whenever delta V is not 0, then acceleration is non-zero as well. If acceleration is non-zero, then resultant force F is non-zero as well. So that means whenever you change direction, you must have a force. Option B, moving in a steady speed, then this is what Newton's first law talk about. Slowing down, that means A is not 0, you have a negative A, so again you need a force. Speeding up as well, so the only answer acceptable is B.